I'm Daniel Singh, and we are from Group 2. The topic chosen is Hotel Self-Service Kiosk System. So now I'm going to talk about the background of self-service technology. Self-service technology (SSTs) are one of the most recent technology breakthroughs that many sectors have embraced. The implementation of SST by adopting a self-service kiosk in business helps in reducing labor costs and enhancing productivity. In addition, it is said that one kiosk plays a role of 1.5 staff members in providing services to the customers. Therefore, the information kiosk system offers a great opportunity to improve the effectiveness and efficiency of the business operation and enhance customer experience. The hotel sector is known for emphasizing the interpersonal interaction, but now customers have another option, check in and out through utilizing the self-service kiosk. It is imperative to increase user friendliness so that they can complete their transaction without assistance from the service providers. This can be done through the implementation of chatbot by automating the processes. The evolution of self-service technology began with the invention of vending machines operated using coins in 1833, launched in London for selling envelopes, postcards, and notepapers at post office and railway stations nationwide. In June 1964, the self-service gas station at Big Top Convenience Store in Denver, Colorado, offered self-service gasoline. In 1992, the first retail self-checkout system, which was known as the service robot, was developed for customers to make purchases at supermarkets. This had made self-checkout to be prevailing in retail stores across America by 2003. Beginning from 2000, the growth of self-service kiosks can be seen from airports to hospitality, where it's a great approach to both reduce congestion during high peak hours and lower labor costs. In hotels and other travel environments, self-service kiosks that dispense information, provide check-in function, or print receipt have become common nowadays, which lead to a whole new experience for travelers or customers.
Hi, my name is Dr. Heng, and my ID is 18SB0263. Now I'm going to present the future trend of self-service technology. One of the future trends of self-service technology is the frictionless store, which allows customers to buy without pay. Due to the high speed of payment through online, it will help a lot in a quick service restaurant and fast casual industry in the future. Next is the artificial intelligent robot, which help people in laboratory work or some dangerous work. For example, some food that worker receive payment return change and many other tests. It can help in many industries. Next is the problem statement. The problem statement is insufficiency of staff during golden time, difficulty of operating hotel business due to COVID-19 pandemic, fierce competitive amongst the hotel business. Next is the objective and the proposed solution. The objective of the project is to develop a tool that makes use of the existing cloud provider that can help the hotel to manage their business and help to improve the hotel business within the pandemic situation. The proposed solution is the hotel self-service kiosks using a service provider AWS, Amazon Web Service, with the help of chatbot that can perform variety of service to solve the problem mentioned previously. It can solve the insufficient staff issue with the automations of service process through the chatbot. It can reduce the amount of physical contact between staff and the customer, and it also acts as an attraction point to attract more customers from the hotel.
Hello, my name is Fu Sun. I will now explain the usage and flow of each services used in our solution. The architecture diagram of our solution was shown in the slide. Firstly, the input devices such as kiosks and user devices should be connected to the internet. The guest can use the kiosk or the hotel website to check in or out, refund, and request services. The front end of the hotel website will be built using Amazon Amplify. AWS connector will be used for user authentication, such as user sign up and user login for the hotel website. AWS Gateway API will be used for API connection from the web application to our main chatbot system, Amazon Lex. Amazon Lex is mainly used for customized user interaction, such as order room or food, customer service, check promotion, and others. Amazon Lex build will be automating the informational response to the frequently asked question by the hotel guests. After the user perform event on Amazon Lex, the user request will be sent to the Lambda for processing. One of the events to be triggered is to perform validation on the user request from the chatbot conversation. It will validate the user output answer and inform them the correct way to input if they input wrongly. Lambda will then send back the reply to Amazon Lex after processing, and Amazon Lex will display the output message to the user. Besides that, Lambda is also used to store and retrieve the booking transaction fetched from the conversational in the chatbot system into DynamoDB. DynamoDB will contain multiple tables related to the question asked on the chatbot system, such as receipt and customer information. Then, the data in the DynamoDB will be connected to Amazon Athena. In Amazon Athena, we can insert a query related to the table in DynamoDB to generate the table result. This query result will then be stored in a S3 bucket created. After that, the query result stored in the S3 bucket will connect to the Amazon QuickSight to perform data visualization based on the table in DynamoDB. Lastly, the Lambda function is used to read the data from the tables in DynamoDB and send out a notification via email by triggering Amazon SNS when the data collected meet a specific threshold. For example, if the system time is near to the hotel guest check-in time, it will send out a notification via email to the hotel guest to provide a reminder. That's all for the architecture diagram. Thank you.
My name is Lee Siang, and I will talk about the study of different chatbot platforms. A chatbot platform allows marketers to build and maintain chatbots for different messengers, and the benefits are provides universal tools for creating chatbots, helps identify the best messengers, and helps track the overall chatbot. The first one is Amazon Lex. It is an AWS service for creating speech and text-based conversational interfaces for applications, and it combines the power and flexibility of NLU and ASR to help you establish new product categories and create highly engaging user experiences. Second one is Google Dialogflow. It is a lifelike conversational AI with state-of-the-art virtual agents. With the virtual agents, Dialogflow provides more natural customer experiences, and it reduces development time from days to minutes with the visual builder and review agents. Third one is Azure Bot Service. It is a set of services that can be used to host a conversational bot, and it offers turnkey infrastructure solutions. And it could be standalone with full logic built-in, or could be integrated into a larger cloud or hybrid architecture. And as for the comparison of relevant technologies, the first one is ease of use. Amazon Lex comes with a simple console that walks you through the process of building your own chatbot. And Dialogflow provides a web interface for building bots. In the case of Azure Bot, a web interface is offered for creating and publishing bots. For the intents and entities features, they are supported by Dialogflow and Azure Bot Service with LUIS cloud-based API service. And Amazon Lex lets you use standard built-in intents and slot types. For the integration support for Amazon Lex is presently restricted to Facebook, Kik, Slack, and Twilio SMS. And Dialogflow integrates with Google Assistant's websites, Slack, Facebook Messenger, Skype, and Twitter. The chatbot produced with Azure Bot Service can be shared across multiple platforms, including the web, Facebook Messenger, Skype, and Skype for Business, Microsoft Teams, and Slack.
So now I'm going to show you the hotel chatbot that our group has created. So in this case, I'm going to show you the demo of the work group. So first we type in hi to invoke the intent. So they are the services provided, work room, order food, check promotion, and customer service. And I have selected the work group. After that, I key in the name, email address, as well as the phone number. So for the type of the room, I've selected single. After that, the user have to key in the time for check-in. So I type 9 p.m. So the business hours are from 10 a.m. to 5 p.m. So I have to key in the 3 p.m. between the time specified. So after that, I have to key in the check-in date. So I key in a room date. So the system says that it must, so the user must check in the room from tomorrow onwards. So I key in another date. So for how many nights would you like to stay? I type in a wrong answer, and the system could not understand and ask again the question. So I type in a 3. So the system asked that do you like to add an extra bed? So I simply type in a words. So the system do not understand that. So ask the user to reply yes or no. So I reply no. So for this validation, and the lambda function is used for the initialization and validation. So these are the code in the lambda function to validate the user input. So after that, I type in yes to confirm the information. So the system show the confirmation of the booking. So after that, we can go to the DynamoDB and refresh the table. So this is the record that we have created just now.
Now I will present our demo about the Amazon Amplifier and Amazon Control. After follow the step in the lab menu, we can create a web app with authenticator and also integrate with the chatbot. Now I will show you the final result of our system. Here is the authenticator using the Amazon computer to verify the user and the password. Now I'm going to continue the demo on the Amazon Amplify and Amazon Computer. After follow the step mentioned in the lab menu, we have created a Amazon Amplify for our web app. Now I will show you the demo. This is authenticators with the Amazon Computer used to verify username and the password. Now I will show you. After logging in, we will enter the main page of our web app, and this web app is for the hotel. Now you can see the chatbot of our hotel, the hotel system chatbot. Let's show you out whether it's work or not. It's work, and every input for the booking every service, you will store the input into the DynamoDB. Will be mentioned by my groupmate later.
We decided to use Amazon DynamoDB to store our data. Here we have already created a few tables and we randomly selected one, and we can see here that there are some data that has been fetched into this database through a lambda function, and they are the customers' details, and this data will be used for analysis purpose. So as in for Amazon SNS, we have already created one topics which is called hotel system, and then after created the topic, we will copy the ARN, and then after that we will go to the lambda function that we have created, which is the hotel notification system, and then the ARN that we copied just now, we will paste it at this line so that it can publish the message in the email, and then we will go back to the SNS, and then we will create one subscription. Protocol, we will select email, and then the endpoint, we will enter in my email. Then I click create. After create, we can see that the status here, it shows pending confirmation, which means that I haven't confirmed the subscription yet. So I will now go and check my email. And then I can see here that there's an email sent to me. So I will click on the link. Then here it shows me that the subscription confirmed. Then I will go in back and refresh it again. Here we can see that the status has been changed to confirm, and then there is a unique ID shown, which means that I have already successfully confirmed the subscription. And that is all for the part of Amazon DynamoDB and Amazon SNS.
Now I will continue the demo for Amazon Athena, S3, IAM, and also QuickSight. First, I have created a workgroup using Athena version 2 and store the query result under the S3 bucket created over here. And then for the data source, I have created a data source to connect to the DynamoDB by creating a Lambda function using the Athena DynamoDB connected. And then for the query editor, we can run the query using the data from the DynamoDB data tables. After running, we can see the records retrieved from the receipt table from DynamoDB. Next, for the IAM, I also granted the AWS QuickSight service role the permission to use Athena, S3, and also Lambda. I will move on to the QuickSight. As we can see from here, the dataset was imported from the Athena data source. And then on the analysis tab, we can click on the analysis that was created. And from here, we can choose the specific field list, for example, room type. And then we can click one of the visual type, for example, pie chart. And from here, we can see the data visualization output. That's all for our demo from our group. Thank you very much.